Hello and welcome back. So this is the final step of Web Components in Space, Episode 3. We've been building a set of components with TensorFlow.js, and this set of components, it allows you to track points all over your body. So we have body tracking, we have hand tracking, and the last one, of course, is face tracking. So this is why I'm coming to you as a floating head. We can track points all along your face with the face landmark model that works right inside of TensorFlow. So this is pretty cool, and I figured why not? I'll be a floating head and show off, because I can show off because we're already basically done. So I think the most exciting parts are behind us. We got things working now. This is why I can be a floating head right now. But there's some things we need to do to actually make this module, this set of components, publishable on NPM. So I tried making this work in an application. There were a couple tweaks I need to do, though, a couple of mistakes made along the way. Also, there's some documentation to write, which is handy because we're using the template provided by Lit, and they provide an 11T based, it's a static site generator. This makes documentation for us so we can tweak some things and customize this documentation. So just a couple more steps and we'll have something we can, put on NPM, we can publish it, and we'll be all finished. But like I said, the cool stuff is all behind us. We just gotta tie up some loose ends. So let's get to it. So let's start by looking at our package.json. Obviously, our project name is not LitStarter. Our entry point is not myelement.js. In fact, we don't even have an entry point now. So let's change some of this stuff first. It's gonna be called pose capture. We're setting a version. We do have a main entry point, though, that doesn't exist yet. It's good to have a main entry point as kind of an organized, one file serves everything from the project. So we're going to add posecapture.ts to the source folder. And all it's going to do is export everything we need, everything that's relevant to component users from our pose capture project. So this entry point is going to be called pose capture. We're going to do one final npm run build to transpile our TypeScript, and then do one final git ignore of our pose capture entry point. Now, looking back at our package.json, it's also nice to tell it what files to publish when it goes to npm. So I've added all those files right here, and like I said at the start of this project, these are all files that are just in the root of the project. So this is what we publish. You won't see anything from our source folder when you npm install this, or really anything else. Now we end up with one tiny problem here, which is all of our source files right here, all of our TensorFlow source files right here, they import from our libs folder, which lives in our root. And once all our source files get transpiled to JavaScript, they end up at the root. So this path right here, it changes from when you're using development or when you consume this package. So I think the correct thing to do here is make sure our libs folder lives in the source, but it's also copied to the root of our project as well. So I'm gonna tweak our rollup configuration to make sure this happens. So that rollup configuration lives right here. We're just gonna change the directory that it publishes to. So we've changed it from libs to source libs. And at the very end, I'm adding one copy task right here to take everything that was in source libs and add it to the root, which we're gonna need to add the rollup copy package to our package.json and install that. Now, just to get Rollup doing this as a separate task, I'm adding a dummy file that serves as an entry point for Rollup. It's kind of a weird hack to do what I want to do, but I need an entry point to give to Rollup to do this one final task of taking everything it generated and dropping it into the root. So I'm going to do one final lib pre-bundle here. And with that, we have the TensorFlow libraries in our source folder and in our root. So either one can consume them. And then in each one of our TensorFlow solutions, we're just going to need to change the path slightly so it points to the right path relatively. Now, overall, things are looking pretty consumable for the outside world at this point. I do want to change one thing. So the lit template that we used did give us a rollup configuration file. Now this is for generating bundles, which they don't recommend you actually publish. What the bundle is good for is actually doing some internal things. So I'm going to make this all work, which just means using our pose capture entry point instead of the default one. So if we're not using our rollup bundle to actually ship our components to people, what are we actually using it for? Well, there's some handy stuff inside our repo here. You can see this by looking at the package.json files. So right at the bottom here, we have this check size task. Well, this relies on actually bundling the application and then finally checking the size. So let's run that real quick. And you can see right now it's doing the bundling and everything it needs to do to, piece all these files together and then finally give us an actual result. So yeah, we're using TensorFlow, so it's a bit big. 3.6 megs is a bit big for a component, but again, TensorFlow is a huge thing. So it's good to have this information available for us so we can maybe try to cut some things out if we're concerned about size. So in terms of other tasks we have, check this one out. It's called Analyze. And what this one does is it analyzes our component based on that bundle. So it needs that bundle as an input, but then it runs a tool on it to generate a custom element manifest. So let's try that out. npm run analyze. And yeah, it says it created a new manifest. So this is that manifest, that custom elements.json file. This is going to be pretty handy for our documentation. You'll see why. The last one I want to mention is documentation, and this is a big one. So this lit template we're using, it has the 11t static site generator built right into it, so we can start using it. It already has example content as well, so we can build it right now, and it uses this bundle that we made from Rollup to drive some of those examples. npm run docs build. It took a bit, but it did all of those things I just mentioned. It's using the bundle, it's building the bundle, it's analyzing the component, it's checking the size, but more importantly, it's building the docs. So let's take a look at these docs next. So this content is completely driven by Markdown files, and there's sample content already in this repository through this template provided by Lit. It's all based on 11t, the static site generator. And all I was doing is I'm replacing content to make this documentation my own. And you can flip over to the examples here and see that, yeah, we have examples running right in our browser right here. And it's a very limited set, exactly what we intended, because we didn't want to, include the world like Storybook tends to do. And we have code examples with CSS and HTML. I'm showing full body visualization right now, but we can flip it over to hand visualization, face visualization, or even just the pose recording. And if we click on this API tab right here, we can load this long API documentation, and this is what the custom elements.json can give us. So right here, of course, we have video element, and it has a number of properties, has a number of attributes, all listed in this documentation. I won't get into how to customize 11t like this because I think that's something easy you can learn on your own. But it's nice that this template from Lit, it gives us everything we need, from creating our initial component to, doing testing, which, yeah, we ignored. But the infrastructure is there for, doing our internal demos for when we're doing development, and also, doing an external demo for creating this page that we see right in front of us for, just advertising our component, listing out the API, giving some examples, all the stuff we can just put on GitHub. It's not as stiff as something like Storybook, which, like I said, Storybook is great for other situations, but I don't think it's good for ours. So overall, I'm really happy with this Lit template. I think I'm about ready to wrap this up, but I did create a nice little reference application so you can see all of this in action. To get this demo application working, I did have to publish our post capture component, which is right here on npm.js. Now, I won't get into really anything about this demo application that I built, other than just to say, I built it to prove out this component would work well in an external application. Now, I will show you our npm installed component right inside our demo application. So you can see when we look at this file structure right here, this is all the stuff that got transpiled from TypeScript to JavaScript and got put at the root of our project. And there's nothing else here. And the reason for that is our package.json file where we explicitly said what files that we want to publish. And so, of course, you're not getting any of the source files for the documentation or the sample video files. Everything's here just to be a lean, mean pose capture element machine. Now, like I said, we're not going to get into how this demo application was built. It's just an ordinary lit project, but I will do some demoing. So let's do that. npm run serve. And now what we have is not that far off from our demo files. It's just in a more structured application. So we can load up our pose player with any number of these demo files, but also just load up a video player that we can capture points from. So here we are. Actually, I'm going to close this out with face landmark detection. These points are all drawn through the face landmark model using TensorFlow.js. This application that we're in is built using the pose capture component that we built today. This application is on GitHub. The pose capture component that we built today is on NPM right now. And I do want to apologize. We breezed through so much code. I was kind of dropping in files left and right in this component as we were building it. But there's a lot. It was a complex component. Obviously, it does some complex things if you look at all these points that are being drawn. It's kind of amazing in what it does. And so I wanted to focus on some of the problematic areas when creating a component like this and going through and publishing it on NPM. The most complicated bit, I feel like, the most troublesome bit was taking a common JS package like TensorFlow is and making sure it works as ESM, as an ES module. So yeah, there was some trouble there, and there were some cool things we learned along the way as well. I think the most fun I had, though, was talking with Jason Mays. He's the lead developer advocate for TensorFlow.js, but I also want to thank the lit folks, the other Google folks, for creating the starter template. This starter template, you know, I am normally opposed to starting anything not from scratch, but honestly, it was super helpful, gave some good organizational ideas for starting out a component and getting it published in a nice, organized, and consumable way on NPM. So thanks to Google all around, from Jason Mays to the lit team. So this was a lot of fun to build. We focused on a lot of different problems that popped up for creating something this complicated, but I think in the end we have something awesome. And you know, happy pose capturing, I guess. Until next time, later. This is Web Components in Space. We'll build something cool in the next episode as well.